but I will. Oh boy. Let's see. Yesterday I also gave a chapter test in AP Calculus. So I started grading those last night. So let's see, what time did I start grading those? 10:30. So I spent about 2 hours grading those. I will finish them today, I hope. And then I will do your quizzes after that. So I'll start grading them either tonight or tomorrow, I believe. And then, was anybody absent for that? Where'd you go?
I was in my locker.
I thought you were, oh, okay, all right.
I just dropped my CD.
Okay, that makes sense. All right, but either way, so I'll start grading your quizzes tonight, I think, or tomorrow. Just depends upon how much, when I get my other stuff done. Does anybody need to take that quiz? Was anybody not here yesterday? I think we were all here. Okay. That was still, again, on proofwriting, which we'll spend, honestly, probably the next week and a half doing, probably a week and a half, doing similar proofs to what you did on your quiz yesterday. So we'll still do more proofs. Today in class, though, the proofs that we did in class today, I think went much better with my fourth period class than they normally go. So hopefully that's the case with you guys as well, too. We feel a little more confident about proofs, okay? All right. So let's do this. 2.8. Sam, I'll get out of your way in a second.
I can see it.
Can you?
Yeah.
All right.
Can I sit in the Pacifico chair?
I usually sit in the chair. You don't even have an iPad.
So I can like look over.
You know what you should do is write this out with a piece of paper and pencil. That's what you should do.
Oliver can share this with me later, and we're gonna every other one of us are gonna do the other problem.
Okay. We'll see how that goes.
Yes, sir.
I believe. I'm trustworthy. All right, hey, I want you guys to start by looking at the warm-up. Boom. Okay, so it says, give a reason to justify each one of these statements. Okay, so we just need a reason to answer one of these. And your answer to these questions would be like a reason you would put in a proof. So angle 3 is congruent to angle 5. How do I know that angle 3 was congruent to angle 5? What reason would that be? Wouldn't be definition of congruent angles. Good guess, though.
Definition of vertical angles?
Vertical angles. Good. So we would say, because if you look at 3, 5, those are vertical angles. That's how I know that they're congruent to each other. Now, we have a name for it, and we're actually going to learn it today, but I'm just going to write it now. It would be the vertical angle theorem. You're going to learn that today. Okay? All right? Okay. What is that symbol again for 2? DE, and then what is that? Very good. Perpendicular. So DE is perpendicular to DG. I forgot to put an if there. Then angle EDG is a right angle. Well, what would we use to justify that? If I know that they're perpendicular to each other, how can I say it's a right angle? Because. Anytime that it's typically like a because statement, it's probably a definition. So we would say definition of what, do you think? Perpendicular. You have to use what they gave you, which is perpendicular. So I would say definition of perpendicular lines. All right, 3. If angle 1 and 4 are supplementary, then the measure of angle 1 plus the measure of angle 4 equals 180. So that's another definition. What definition do you think that would be?
Definition of supplementary.
Good. So definition of supplementary angles. Couple of things. Oliver, you asked for like a word bank yesterday or the day before or something like that. Just like having like a bunch of reasons that you can pull from. I think I'm going to make you one. It won't be one that you can use in like tests and quizzes, but I think it would be a good activity for us to be like, hey, these are the things that you know, and these are the things that you can use on your proofs. I do it in chapter 5 I guess I don't know what chapter it is in this textbook, but I've taught geometry for a while. And I would always do it right when we were doing triangle proofs. So I was going to do it with you guys eventually, but I think it might be beneficial for us to do it before this chapter 2 test that we have coming up. So I'll make something for you. We'll go through some stuff together, okay? And then aside from that, speaking of test and quizzes, you guys are going to take a quiz on 2728. That will be Monday, would be my guess. And then we'll review for a chapter 2 test that we'll take later that week. Okay, so we'll do a quiz Monday next week and then a chapter 2 test probably like Thursday or something like that would be my guess. Okay. Friday I'm not here. General reminder, I won't be here on Friday. So I'll have you guys do some activities on Friday in class. But okay, now let's get into the theorems that we're actually going to learn today. So we're going to do more proofs. We're going to do a lot of stuff with angles today. So a lot of the proofs that we're going to do will be related to angles. So remember some angle relationships that we know already are supplementary and complementary angles. We talked about also congruent right vertical angles, linear pairs. So those are all things that we talked about before. Supplementary angles are angles that add up to what? And then complementary is, yeah, so we got to keep that in mind. Okay, first theorem is what's called our supplement theorem. So if two angles form a linear pair, then they are supplementary angles, okay? So we could say by the supplement theorem, if you have two angles that are a linear pair, then you can say that they are supplementary to each other. If I drew a little picture of that, two angles that form a linear pair would look something like this, angle 1 and angle 2. Obviously, those are going to be supplementary to each other. So we would say the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And then we can use that same logic with complementary angles. So complementary angles are angles that add up to 90. So if I have two angles that add up to 90, then I know if two angles form a right angle, then they are complementary to each other. So if I do 90-degree angle, if I have angle 3 and angle 4, then I could say the measure of angle 3 plus the measure of angle 4 equals 90. Okay. All right. Let's get into our first example. So about vertical angles, or no, linear pairs, my bad. If 1 and 2 form a linear pair and 2 is 67, find the measure of angle 1. Okay, so if I know they form a linear pair, then I can go ahead and say that the measure of angle 1 plus the measure of angle 2 equals 180, right? Because it's a linear pair. But I know what angle 2 is. Angle 2 is 67 degrees. So I could say that measure of angle 1 plus 67 equals 180. Now I'm writing this out the long way. But if I subtract 67 from both sides, I can find angle 1 that way, right?
Yes, sir.
So what would that be?
133.
Close.
23.
Less, more close.
What?
113.
You were so close, Oliver.
Dude. Oh, I was thinking that was 200.
Yep.
113.
He was. If it was 200, it would have been 133. 113. Okay, so if angle 1 and angle 2 form a right angle, and the measure of angle 1 is 16, find the measure of angle 2. Do you have to write it out like this? No. I'm sure that you guys can do it much quicker by just being like, okay, well, I know I need to take away 16 from 90, right? But I think you guys are good equation writers, so I'm going to take the time to do it. Take 16 away from both sides. I get the measure of angle 2 equals, Oliver, redemption, buddy.
74.
74, he did it.
Oh, that's good.
All right, good there? Okay. All right, let's do some more theorems, okay? So angles that are supplementary to the same angle, or congruent angles, are congruent in and of themselves. And then angles that are complementary to the same angle or congruent angles are also congruent. Let me draw a little picture of what that's talking about there. So if I have two angles that are, first one's supplementary, right? So let me actually draw that a little different. Let's say we've got this angle here and this angle. And then I also have, I don't know, this angle as well too. let's say it's angle 1, this is angle 2, and this is angle 3. Okay, so if I know that angle 1 is supplementary to angle 2, and angle 1 is supplementary to angle 3, then like, I don't know, let's give a measure for angle 1. Let's say it's like 140 degrees. What would angle 2 have to be? If angle 1's 140, what would angle 2 be?
Who knows?
Molly knows. What is it, Molly?
40.
It'd have to be 40, right? Because they're supplementary, they would add up to 180. Okay. But if I also know that angle 1 is supplementary to angle 3, and angle 1 is 140, what would angle 3 have to be? Also 40. So that's why angle 2 would be congruent to angle 3. That's what that theorem is saying. Okay. We can do the same thing with complements as well, too. So if I have two angles that are complementary to each other, angle 1 and angle 2, and then I know that angle 1 is also complementary to angle 3, then 2 and 3 would also have to be the same as well, too. So if angle 1, comp to angle 2, and angle 1, comp to angle 3, then angle 2 would have to be congruent to angle 3. They have to add up to 90. 1 isn't changing. So then the rest of it that needs to get to 90 would have to be the same between the two angles, 2 and 3. All right. Hey, what did we say about vertical angles? You bet your bottom dollar they are. So that's what this theorem says. If two angles are vertical angles, then they are congruent. We're going to use that a decent amount in this section, but really, when we start getting to triangle proofs in chapter 5, we'll use vertical angles a ton. So I put a very small gray star next to vertical angles theorem. Okay. All right, if 1 and 2 are vertical angles, and 1 is x and 2 is 228 minus 3x, find the measure of angle 1 and the measure of angle 2. So I need to set up an equation in order to do so. What equation would you set up for number 3? What do you guys think?
Angle 1 plus angle 2 equals 90.
Not quite. They're vertical.
Is it
Dude. Oh.
2?
I mean, no, never mind.
Measure of angle 1 equals,
Measure of angle 2.
yeah, they're congruent, so they're equal to each other. So then I would set x, which is the measure of angle 1, equal to 228 minus 3x. And then I would solve. And you guys are good equation solvers. First step, x and 3x is 4x equals 228. And then divide both sides by 4. 200 divided by 4 is 50. 28 divided by 4 is 7. It's 57. But remember, the question itself says find the measure of angle 1 and the measure of angle 2.
Plug it in.
Plug it in. A lot of you guys missed easy points on your assessments so far because you didn't plug things in. This one's pretty simple though. Measure of angle 1 is just going to be x, which is 57. Measure of angle 2 should be the same thing because they're vertical angles. 228 minus 3x, which would be... 228 minus 3 times 57. All right, 3 times 57 is 171. So then you would do 228 minus 171. Shoot. Switch to a black crayon. 57. So they are both 57 degrees. All right. Feeling okay? We haven't really gotten into the proofs yet. You guys ready? Proof time, baby. So ready. All right. 1 and 2 form a linear pair. Is it Oliver's turn to do it now?
No.
Okay.
Somebody's covering. No,
I thought you guys were switching back and forth. 1 and 2 form a linear pair, and 2 and 3 form a linear pair. Prove that angle 1 and 3 are congruent. Okay? Carter's gonna help us get started
What's wrong
here.
with four?
What?
Four's not involved?
4 got no love, huh?
Yeah. Alright.
4's not included at all. Probably should have given myself some more room on the statement side. That's all right. Make it work. Okay, what am I doing first?
Right now you're giving.
Yeah. I'm just going to write it as 1. I know in past I've written it as like 2 separate steps, but let's write it as 1. So angle 1 and angle 2 form a linear pair. And then I can say the same thing, angle 2 and angle 3 form a linear pair. And my reason for that is given. A common question that we have had with proofs over the past week and a half or whatever it's been is, what do I do? Where do I go, right? That's the tough thing with proofs is knowing like, okay, what do I do next? Of course, you guys all know to write your givens, but then what to do next is a common question. Here's how I would answer that. If you can, then use your given. So like if your given is a vocabulary word or something like that, then use that vocabulary word to write your next statement. What does it mean that 1 and 2 form a linear pair? What can we say from that?
They're equal.
Not that they're congruent. Yeah, you could say they're supplementary. What are you going to say, Oliver?
Oh, I have no idea.
Bryce, help him out.
They're equal.
Not quite.
1 and 3 are vertical.
Molly, say it again for the people in the front.
They add it up to make 180.
Yeah, so I would say, that's what who said?
Me.
What did you say they add up to equal 180?
I said they're supplementary.
That is true, but not the same thing.
Okay.
Wait, why?
It's kind of the same thing, but
So is a linear pair always 180?
yeah. Yep. So I would say measure of angle 1 plus the measure of angle 2 equals 180. And then I could give the same treatment to 2 and 3. You guys agree?
What's the reason for that?
That's a good question. We'll do it in a second. Measure of angle 2 plus the measure of angle 3 also equals 180. What's the reason for that? How did I know they added up to equal 180?
Oh, because
Definition of linear or something.
Good. Carter, were you going to get there?
no, I think I was gonna say like reflexive or something.
No, that wouldn't have been good.
Like definition of what?
Linear pair. We need to use what we are given. They told us it's a linear pair, so that's what we're going to use as our reason. Okay, from there, where you go in your proof, it just depends upon what you've written so far. I know 1 plus 2 equals 180 and 2 plus 3 equals 180. Where I want to get to is I want to show that 1 and 3 are the same thing.
So substitute.
Substitute what?
The 2's. So it'd be
I like that.
angle 1 plus. Wait, measure of angle 1 plus measure of angle 3 equals 180.
Not quite.
Okay.
I would, if I did that, I would have to know that 2 and 3 are the same, because what it sounds like to me is you substituted 3 in for 2. I'm going to use substitution, but I want you to try to.
Substitute. Yeah, can't you substitute the 2 because they're both equal to 180?
Okay, so I can't necessarily substitute the 2, but I can substitute those 2 statements together. I'm gonna give you one more time. Brielle's busting at the seams to tell me what it is.
180?
Okay, we have to do something with the 180.
Substitute it.
Okay, so what's that gonna look like?
Measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3.
Yes! Good! Yes! Brielle, is that what you're gonna say? That makes me very proud. We got there. We did it. Wonder how loud that's gonna be on the screen recording.
Yeah, that was pretty loud.
It was the loudest I've yelled in this school so far. Substitution property. Good job, team. Now. Go ahead, Raph.
Never mind.
No, say it.
No.
Say it.
No, I was wrong.
Well, how do you know?
Because I did it in my head.
Well, look at where we want to get to, right? We want to.
Because I was thinking of take away measure 2 on the side.
That sounds fantastic.
What you did.
But what did measure of angle? Oh shoot, forgot.
So what would that give you,
We
Raph?
were trying to get 1 equal to.
I'm trying to get 1 to equal to 3. So if I take away 2 from each side, what do I get?
3.
Good.
Subtraction. and then one after definition of congruent segment.
So let Oliver tell me what reason that's going to be.
Come on, Oliver.
Subtraction.
Wait, how come sometimes that's substitution and sometimes that's subtraction?
When?
Like, a couple times, like, if you, like, it looks like you're subtracting, but you're really substituting.
Oh, that's a great question. It's because in this case, I took away measure of angle 2 from both sides. But in the past, sometimes we would do, like when we did segment addition postulate proofs, right? We would have things that look like this, you're right. But what we were doing is we'd be replacing all of like this big statement 1 plus 2 with something else that's smaller.
Okay.
But that's not what I'm doing here. I'm taking away 2 from both sides. So it just depends upon what you're doing. That's a really good question, though. All right, I have one more step, Raph. What is it? Make them congruent instead of equal, right? Because I want my proof statement to be exactly this. So I would say angle 1 is congruent to angle 3. Okay, this is a bit tricky, but I believe that you guys can do it. What is our reason?
Definition of congruent angles.
Yes, not segments, but angles, because we're working with angles this time. Very good. Oh my gosh.
I should move here.
Huh?
I should move here permanently.
All right? You are locked in somehow.
Yeah.
Originally, in my teacher brain, I was like, well, I don't know. This looks distracting. Are they going to pay attention? But I'm like, you know what? I'm just going to let it ride. We'll see how it goes.
What are those medals for? For the, yeah.
I'll answer that after I'm done. It's for running, for like running 5Ks and half marathons and stuff.
Oh.
So, all right. Back in the days when I actually had time to run and exercise and enjoy those kind of things. That'll be next year. This year I have no time. I don't think you guys understand. I have no time. Next year, though, I'll have time so I can do fun things.
What's that?
I spend all night working on school stuff because this is my first year here, so I have a lot of work to do. I'll explain afterwards. And plus, you guys don't need to hear about me complain. You know. All right. It's not complaining, though. I'm happy. Very happy to be here. All right. Given the measure of angle 1 equals measure of angle 3, we want to prove that AEC is equal to DEB. Now, we've done some proofs like this with segments. We haven't done one like it with angles. Before I dive into looking at the picture and everything, though, let's just do statements and reasons, get that out of the way. Write our givens. Okay.
You don't take points off on a test if we put S and R instead for statements and reasons.
Put statements and reasons, Parker. Listen, that little amount of shortcutting is going to manifest itself into a larger problem. All right. So 1 is equal to 3. That's what they tell me. That's my given. I want to prove that these two bigger angles are congruent to each other. So if I look at my picture, I've got, okay, I see where angle 1 is. I see where angle 3 is. Those two pieces are congruent. Let's look at where I want to go. Because, like, there's no definitions I can use there, right? So, like, in the last problem, I started by, like, writing what my definition said. They didn't give me any sort of definition or vocab word to go off of. They just said, hey, these two angles are congruent. Prove that two other angles are congruent, okay? So it's kind of going to be similar to a segment proof that you guys have done already. But I want to prove that AEC here, you know what? Let me change the color a little bit. Can we do that? So I'm going to step out of the grout for a second. I want to show that AEC is congruent to angle BED. Okay? So that's, if I draw that, though, that makes that picture a bit busy for me. So I'm just going to go back and look at one of them. So if I look at AEC, what is that big angle consistent of? What is it made up of? 1 and 2. Okay. And then what about BED?
1 and 3.
Not 1 and
2
3.
and 3.
2 and 3, right? So what's common between the two?
Those.
Angle 2, right? Okay. And what do I know about 1 and 3? They're the same. So I need to use those things in conjunction with each other to figure this out. Molly, you started on something. What were you going to say?
I said angle 1 plus angle 2 equals angle
Okay, so if I use, you said what?
I don't think that's right.
It is right. Because you used this statement right here, and what did you do to both sides of that
Oh, I
statement?
see.
I just added angle 2.
Just added angle 2, right? This is the same thing that we did for the lines, right? So Molly's saying, hey, I'm going to take this statement that I'm starting with, and I'm going to add angle 2 to both
So
sides.
that'd just be SAP.
Close. Well, not yet. I know where you're going with that. We're going to get there in a second, Carter. What did you do, Molly? What property would that be? Yep. So we would say that is addition property. Okay. All right. Now, we're going to do something related to what Carter said. What'd you say, Carter? You were talking about,
I see.
yeah, but since we're dealing with angles, we would do angle addition postulate, right? Instead of segment addition. So what two angles, what's that going to look like? Because when we did angle addition postulate, we said we would say, or if we did segment addition postulate, we said small segment plus small segment equals big segment. Okay?
Yeah.
So if I did it with angles, I would do small angle plus small angle equals big angle. Tell me what that would look like here.
Would that be measure of angle 1 plus measure, wait, plus measure of angle 2 equals measure of angle 1 plus measure of angle 3?
Give me letters.
Oh, letters?
So angle 1 plus angle 2 gives me what letters? Measure of angle,
AEC.
yes. Yay. And then let's do the same thing for the other angle.
Uh,
Measure of angle 2 plus the measure of angle 3 gives me what?
BED.
BED.
AEC.
Mm-hmm. Brother. Measure of angle BED. I think they said DEB, but it doesn't really matter. It wouldn't bother me if you guys said that. AAP. I'm going to write in parentheses, though, angle addition postulate. Okay. All right, we're almost there. Now what can I do?
Substitute.
Substitute, right?
Uh-huh.
Yep.
2.
So I would do AEC is 1 plus 2. So that's going to go in here. And I know 2 plus 3 is BED.
Yeah.
So I'm going to substitute that there. So I would say the measure of angle AEC is equal to the measure of angle BED. And what would be the reason for that?
Substitution.
Very good. Let's check with what I wanted to prove. Yep, they use measure, so I don't need to change my notation at all. And there we go. I feel like we're starting to get it.
I think this is easier.
Now we're good.
Okay? It's because we practice it more, right? It was novel when we first learned
I
it.
feel like that, like the like what it shows you is like way more like easier to like understand, like just like a lot.
Not yet. Yeah. Okay. All right. Cool. Let's do a couple properties, talk about a couple theorems, and then I'll give you guys your assignment that you can finish here in class, actually. All right. Congruence of segments and angles is both reflexive, symmetric, and transitive. Not both, but they're all those. So when it comes to, we talked about like reflexive property of equality and symmetric property of equality, but we didn't talk about it with congruence, but it operates the same way. So reflexive property of congruence would be like if I have AB is congruent to AB. Okay? So the same thing on both sides. There's no if and then statement. It's just one short statement of something being congruent to itself, reflecting in the mirror. Or I could say that like angle ABC is congruent to angle ABC. Okay? And I know that reflexive property seems silly, that it's a thing that exists, but when we get to chapter 5, much like vertical angles theorem, we will use reflexive property a healthy amount. One might even consider it to be an unhealthy amount. Hey, symmetric property. Do you remember what we do with symmetric property? That one has an if-then statement. You flip it. Good, Molly. So then if AB is congruent to DE, then we could say, good. All right. And if angle ABC is congruent to angle DEF, then what would that look like? Good. DEF is congruent to angle ABC. Okay, and we've done transitive property before, so let's just put that in congruence. If AB is congruent to DE and DE is congruent to GH, then
GH is congruent to AB.
yeah, I'm gonna flip the order that you said. I'm gonna say AB is congruent to GH, but you're right.
Well, I thought if it was transitive, you'd always repeat. You'd always repeat it immediately.
Yeah, and it is repeated, like the DE is repeated, but then you do this part and that part. The AB and the GH. All right, if angle ABC is congruent to angle DEF and angle DEF is congruent to angle GHI, then what? Angle,
GBC is congruent to GHI.
good. Okay. All right, one more slide, and you guys can practice some stuff. All right, these are just a bunch of miscellaneous theorems that like don't really fit anywhere else, but are theorems that are true, and you can use them in proofs. I'll name the second one, but the rest of them don't really have names. I tried to come up with names for them last period and failed miserably. So, all right, if you have perpendicular lines and they intersect each other, how many right angles does it form?
2.
Nope.
4.
4. Yep. Perpendicular lines intersect forms 4 right angles. So at each corner, you get a right angle. Okay. All right angles are congruent. That makes sense, right? No matter where a right angle is going to be, they all measure 90 degrees, so they'll all have the same measure. We are going to call this our right angle congruence theorem. I don't think I can use the calligraphic pen on this one. For whatever reason, it doesn't let me. It's only if it's in PDF. Womp womp. Way to go, numbers. All right, perpendicular lines form congruent adjacent angles. Well, let's think about what that means. Perpendicular lines form congruent adjacent angles. That makes sense because the angles right next to each other are both right angles. So the adjacent angles, the ones next to each other, are going to be congruent. So that makes sense to me. Okay. 2 angles are congruent and supplementary, then each angle is a right angle. So if we have supplementary angles and they are congruent to each other, angle 1 and angle 2, and then that means that measure of angle 1 equals the measure of angle 2, which would have to be 90. It's the only way they would both add up to 180 if they're both the same. And then if 2 congruent angles form a linear pair, then they are right angles. It's kind of the converse of what it was up above. So 2 angles form a straight line, and they're congruent, then they have to be right angles. Does that make sense to me? Okay. All right, questions there? All right, I'm going to give you your worksheet. We finished quick today, y'all. Might even be able to do a round of questions or two in the last like 10 minutes or something. It's been a while since we did those, hasn't it?
Yeah.
Not many. We'll go ahead and put those in the bottom of the stack here. All right.
This is the
Get that in the car.
Do you keep your guitar there every day?
Yeah, I don't think it matters. I have a couple other ones at home. Honestly, I just have not had time to play it all. I should play. I I should. I wish I played
Yeah,
more.
I-
I used to do it during like my old school. I do it during my planning period or just whenever I had time. But I just like I have no time anymore.
Play some Matt song.
What'd you say?
Yeah,
Yes. What'd you say?
Song about you.
A geometry song? Maybe we write. Yeah, go for it. Maybe we write a geometry song as a class together.
really.
I'll come up with some chords, and then you guys can just sing over it. I like it.
Mr. P,
Yo,
give one of those worksheets to Jillian.
you gonna see her?
She's like my next one.
Okay. Okay. Let's talk about this worksheet real quick. And if you guys want, I can do the first one with you guys. It says write a 2-column proof for the first one. So there's a proof for that one. On the back, there are 2 more proofs. One of them is a fill-in, and then one of them is a fill-out proof completely yourself. But then there's a ton of properties on here. So like 2 through 13 are all properties. So you guys are just saying the property definition, postulate, theorem, or whatever that justifies that. And then 14 is a fill-in proof. And then 15. It's gonna fall. It's gonna fall. It's gonna fall. There you go. All right. And then for 15, I'm sorry the picture's so terrible. It's so pixelated. I don't know how that happened. But either way, you got to prove that angle 1 is congruent to angle 3. And they tell you that the big angle is congruent. It's kind of the opposite of what we did in class. Okay?
Wait,
You guys
so
wanna-
do number 1 with us?
Do you want to?
Yeah.
All right. Don't look at this. Don't look. Don't look. You're not looking. Don't look. Don't look. Yeah, all right. Okay. Hey, so it says angle 1 and angle 3 are complementary, and then it says 2 and 3 are complementary. We want to prove that angle 1 is congruent to angle 2. I get to use my calligraphic pen this time. It's exciting for me and me only. Okay. I didn't really give a lot of room here. I'm going to try to make it fit. Okay. What am I listing first? Yeah.
Equal them both. Angle 1
Well, I'm going to say, yeah, angle 1.
plus angle 3.
I'm going to say angle 1 and angle 3 are supplementary. I have to say my given first, right? Complementary, my bad.
Yeah. I'm talking about after the
Mr. P,
Yo.
can you just do transitive property one time? Substitution?
Depends how you set it up
No,
right.
because if 2 or if
You
3
still
is
have to equal them
complementary,
90.
like 2,
Mhm.
and 1 is complementary to 3, then 2 is complementary to 1.
Then one would be congruent to 2, right? I think it's what you're right. This is having you prove that theorem. So we're not going to use the theorem in order to prove the theorem, but in any other case, you can absolutely use that if you need to. But you are using what I taught you. I taught you that if 2 angles are complementary to the same angle, then those 2 angles are congruent to each other, and you're right, they are. But we're gonna write the proof for that. So angle 1 and angle 3 are complementary, and then angle 2. Sorry, I'm not gonna list this as 2. I'm just gonna. Oh shoot. I'm just gonna list it.
Got that whole-
Angle 2 and angle 3 are complementary. Okay. Carter.
So for step 2, I did angle 2 plus angle 3 equals 90. And then below it, I wrote angle 1 plus angle 3 equals 90. I kind of did it backwards.
You did, but whatever. I'll do it backwards too. So actually, I know I lied because I already started writing 1. Measure of angle 1 plus the measure of angle 3 equals 90. And then I can say that measure of angle 2 plus the measure of angle 3 equals 90. What's your reason for that? You can do it.
Is it
Complementary theorem.
I wouldn't say theorem.
Substitution.
I wouldn't say substitution. Definition of complementary. Yeah.
I wouldn't say that.
Definition of complementary angles. Yeah, you can say that. Now what do I do after that, Carter?
Substituted 90 to get measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3.
Okay.
And then you subtract.
Hold on.
Oh,
You're right.
that'd be
Substitution. Okay. Raph, what am I doing next?
What?
What am I doing next?
Minus 3.
Okay. Which would leave me with measure of angle 1 equals measure of angle 2. And what's my reason for that?
Definition of.
Not quite. What did you tell me? You told me to subtract, right?
Oh, substitute, subtraction.
Subtraction property. All right, now, my next, I don't have room to write my next piece. So I'm sorry, I got to write it up above.
definition.
What do you need, Oliver?
Wait, what does number 3 say?
The reason?
Substitution property.
Measure of angle 1 plus a measure of angle 3 equals measure of angle 2 plus a measure of angle 3.
Wait, but you didn't do, never mind.
You good?
Wait, yeah.
I substituted 1 plus 3 equals 90 and 2 plus 3 equals 90. I replaced the 90 with the 2 plus 3. All right, I'm going to write my fifth part up above here because I ran out of room. Does that make sense now?
Yeah.
Okay. Now, what's my last one? You started saying this, Raph. What is it?
Definition of complementary angles.
Yeah, so now I say angle 1 is congruent to angle 2. Not definition of complementary. Not complementary.
Oh, congruent.
Yes, definition of congruent angles. Good. You guys are killing it now. All right, here's what I did with my other class. I'm going to do it with you guys as well, too. Tomorrow, when you come in, what are we going to do with all these problems? Put them on the board. Who wants to put up number 2? I'm going to have you guys claim it. You'll circle it on your worksheets. That way you remember. Who wants to do number 2? You'll have to write the statement and then the reason. Haley, what about number 3? Who can do number 3 for me? Molly will do 3. What about 4? Who can do 4? Emma. What about 5? Who can do 5? Carter. What about 6? Who can do 6? Brielle. 7. Who can do 7? Lucy said that like 4 times yesterday. That's my oldest, by the way. Yeah. 7. Who can do? Did someone claim 7 already? Who can do 7? I'll check before you guys leave.
I'll do it.
Number 7. Number 8. Who can do 8?
Parker.
Parker's gonna do 8. Number 9. Who can do number 9? No, you're doing 8, pal. Nope. 9's the easy one. Who's doing 9? Everyone's getting. I'm not doing the homework. Just chalk up the whole assignment. What about 9? Who can do number 9 up on the board? No, you're doing 8.
You can do 2.
Number 9, Mallory. What about 10? Who can do 10? Everyone's putting 1 up. You shy peoples are going to put 1 up too. You might as well claim it before we get to the proofs.
Oh, I got it.
Lena, 10. Cleo, you want to do 11? Bryce is 12. Who's 13?
Yeah, it is.
Maya can avoid eye contact all she wants. She's going to do one of them. Sam's going to do 13. All right, the only thing left are 2 proofs. Who's left? Tisler and Maya, the only 2 left, I think. Right? And Alex.
Someone's not doing anything.
See, like, I get here late.
Okay, all right. But hey, you were here on time today. Won't you be here on time tomorrow?
Probably not.
I'll save it for you, pal. We won't even do it. I'll just be sitting there with your name on it. You got it, buddy.
He's going to be 6.
Yeah. The nurse's office, actually.
Oh, man.
All because of homework.
Who wants to step up and do one of the proofs?
That'd be good,
Alex? Yes. Heck yeah. Before you guys leave, I will check it and make sure it is right. All right, then here's 15 between Maya and Tisler. If neither one of you claim it, you're just going to do it together.
I don't have a preference.
You don't have a preference? I'm going to have you do 15 then.
15?
Yep. The proof. And me and or Molly will help you out if you need it. I think you can do it on your own, but if you want some help, it is there offered to you. All right. Work on not only your problem, but the other problems as well, too. You guys have 11 minutes.